There it is. Let's erase all this, and we'll ask ourselves to sketch the following beast. Here goes. I'd like to sketch y equals x plus 3 cubed times x plus 1 squared times x minus 5 squared. We'll leave it a simple one like that. All right, we'll just play the same game. Are there any interesting x values? Well, yes, at -3, the whole graph wants to be 0. At -1, the whole graph wants to be 0. At 5, the whole graph wants to be 0. Let's put an extreme x value. Let's put in like 1,000,000. They'll have something, basically 1,000,000 cubed plus 1,000,000 squared times 1,000,000 squared. That wants to be positive times positive times positive, wants to be huge and positive. Let's put in x equals like a -1,000,000. This would be basically -1,000,000 cubed. It would be negative. This would be -1,000,000 off by 1 squared, but it'll be positive. This would basically be -1,000,000 off by 5 squared. It'll be positive. So the whole thing this time wants to be huge and negative. Now, let's look at values in between -3 and -1, and between -1 and 5. I know it wants to be negative on the extreme left, it wants to be positive on the extreme right. Let's try a value like, I know, -2. Between -3 and -1, -2, this would be basically 1 cubed. It wants to be positive now. Between -1 and, at -2, this guy wants to be positive. In fact, something squared always wants to be positive. And this guy is always squared, always wants to be positive. So the whole thing wants to be positive between these two values. Between -1 and 5, let's say +2 this time, what's going on now? I'll change color. At 2, this first term wants to be positive. At 2, this second term wants to be positive. And at 2, this term wants to be something squared. It wants to be positive. It wants to be positive again. In fact, right now, I can see the graph has to be doing something like this. It has to go up to 3 where it's 0, and be positive in between. So maybe it does do, and goes back to being 0 again. But then it wants to bounce off to be positive. So this -1 is actually a bounce point. So who knows what it wants to do? It wants to be positive and then down to being 0 at 5 again. And then it wants to be positive yet again. So maybe my graph looks like that. There is a very crude sketch of the polynomial. But people will notice eventually, and I don't want to make this a rule, that with an even exponent, the sign will never change. So either side of -1, where the exponent's even, the sign will never change. That has to be a bounce point. Again, at this 2, this even exponent, either side of 5, the sign will never change. This even exponent point has to also be a bounce point. So some teachers will tell kids for even exponents you've got little bounce points. For odd exponents, either side, the sign will change. It'll be negative one side, positive another. So we'll have cut-through points. But I don't believe in shortcuts that just become memorization techniques. Just doesn't no harm in just thinking your way through. Where's the graph, positive and negative, and off you go. You've got a fine graph of that factored polynomial. And we're done. Thanks very much.